Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1077, refers to an issue concerning the Intake Manifold Tuning, IMT valve. This valve is crucial for optimizing engine performance by adjusting airflow in relation to engine RPM, revolutions per minute. A stuck IMT valve in the high RPM position can lead to compromised engine performance, such as poor fuel efficiency and power loss. The IMT actuator is located within the intake manifold and works in coordination with the Powertrain Control Module, PCM, to manipulate the valve's position. Any issues with this system must be addressed promptly to ensure that engine operations remain efficient and effective. Understanding this code and the parts involved is essential for any diagnostic process. The preceding vehicle maintenance history, including any related DTCs, should be considered for a comprehensive assessment. The IMT valve plays a significant role in engine performance by optimizing airflow based on RPM levels. It adjusts the intake air volume and pathway, ultimately influencing combustion efficiency. This valve is situated in the intake manifold, which is the assembly that channels air to the engine. A stuck IMT valve may prevent proper airflow adjustment, leading to inefficient combustion and subpar performance. The impact on the engine may become apparent in terms of sluggish acceleration and increased emissions. Continuous issues with the IMT valve can also cause other DTCs to appear, which can complicate diagnostics. Proper understanding of the components' functions and locations within the engine system is vital for troubleshooting. There are several possible causes for DTC P1077, starting with intermittent faults within the system. These faults may not consistently trigger the diagnostic code, but can manifest under certain conditions, often leading to temporary operational issues. Poor connections at the IMT actuator, which communicates with the PCM, can also contribute to this DTC. These connections may be corroded, loose, or damaged, impeding proper electrical communication. Additionally, loose terminals may prevent effective signal transmission between the actuator and the control module, leading to miscommunication. Thorough inspection and testing of these components are necessary to isolate the actual cause of the DTC. Symptoms associated with DTC P1077 can be noticeably impacting vehicle performance. Drivers may experience poor engine performance, characterized by a sluggish response when accelerating. This can also result in reduced fuel efficiency as the engine struggles to optimize air-fuel mixture ratios. The check engine light will likely illuminate on the dashboard, alerting the driver to an underlying issue requiring attention. If the IMT valve is stuck in a high RPM position, these symptoms may become exacerbated, showing diminishing returns in power and responsiveness. Recognizing these symptoms can be critical in prompting timely diagnostics and repairs. Drivers should be made aware of the implications of ignoring these early warning signs. For the first troubleshooting step regarding DTC P1077, begin by turning the ignition switch to the on-to position. This action powers all onboard electronics without starting the engine, enabling diagnostic tools to communicate with the vehicle's systems. Next, clear the existing DTC using the HDS or Honda Diagnostic System, which resets the onboard diagnostics. Following this, it is essential to conduct the IMT test located within the inspection menu of the HDS. Completing this test provides initial data regarding the IMT actuator's functionality. The resulting test outcomes will help determine the subsequent steps to follow and whether further diagnostics are needed. Always ensure that previous diagnostic data is captured before commencing these steps. After performing the IMT test, the results will dictate your next actions. If the result indicates that the IMT is functioning correctly, the issue may be intermittent. This suggests that the system might not consistently fail, warranting a check for poor connections or loose terminals at both the IMT actuator and the PCM. These areas often harbor issues that can lead to irregular performance. If, however, the IMT test results indicate a failure, it is imperative to proceed directly to Step 4 for further diagnostics. Identifying whether the IMT valve can operate effectively is critical for determining the exact nature of the issues at hand. This step helps refine your focus towards accurate problem resolution. This step begins with turning the ignition switch to the lock 0 position. This ensures that all electrical systems are powered down before you begin disassembly or reconnections, ensuring safety and preventing short circuits. Following this, disconnect the IMT actuator's 5P connector. This connector allows for communication between the IMT actuator and the PCM. After disconnecting, turn the ignition switch back to the on-to position. At this stage, the vehicle's electrical systems are active again, but the IMT actuator is isolated from the circuit. This step is needed to perform further voltage measurements necessary to diagnose deeper electrical issues affecting the IMT valve's function. Always handle connectors with care to avoid damage. In this step, measure the voltage between the IMT actuator's 5P connector terminal number 3 and the vehicle's body ground. A multimeter is typically used for this measurement to ensure accurate readings. The expected voltage should be approximately 5 volts. This measurement verifies if the circuit is delivering adequate and proper voltage to the actuator, enabling its operation. If the voltage reading is adequate, the system is likely functioning correctly. And you should move on to Step 12 for further diagnostics. However, if the reading is not close to 5 volts, this indicates a potential problem in the circuit that must be addressed. Understanding voltage readings can help pinpoint specific electrical failures in the actuator's circuit. In preparation for this step, begin by turning the ignition switch to lock 0. This action ensures safety and secures the vehicle's electrical systems. The next step is to jump the SCS line using the HDS, which helps clear any potential faults within the system by providing a controlled diagnostic flow. Following this, disconnect the PCM's connector C, which has 49 pins. The PCM, or Powertrain Control Module, is the vehicle's brain, coordinating various functions, including the IMT operation. By disconnecting the PCM, you can explore potential wiring issues between the PCM and the IMT actuator. This step serves to isolate the automotive circuitry to identify where failures may reside, enabling a more focused repair strategy. This step involves checking for continuity between the PCM connector terminal C11 and the IMT actuator's 5P connector terminal number 3. This continuity test is crucial in ensuring that there are no breaks or faults in the wiring between the two components. A multimeter is used to measure continuity. A lack of continuity indicates a potential wiring harness issue that could be causing DTC P1077. It is essential to ensure that the wiring is intact and free from corrosion or damage that could disrupt electrical flow between the PCM and IMT actuator. Verifying this connection can either confirm the integrity of the circuit or direct you towards repairing or replacing the affected wiring. Continuous communication between the actuator and PCM is vital for optimal engine performance. After all necessary repairs or adjustments have been made, it is crucial to conduct a final verification of the repairs for DTC P1077. Start by confirming that the IMT valve is functioning appropriately. Then, clear any diagnostic trouble codes using the HDS, followed by retesting the system. This retest will help ensure that the fault does not recur and that the IMT valve operates within the required parameters. Observing normal engine performance and behavior without any further DTCs appearing is the ultimate goal of this step. Conducting this thorough verification ensures that the vehicle operates efficiently and that the issue has genuinely been resolved. Effective troubleshooting culminates in complete system integrity. Preventive maintenance plays a critical role in avoiding the recurrence of DTC P1077 or similar issues in the future. Regular diagnostic checks can help catch potential issues before they lead to significant faults or performance problems. Establishing routine schedules to inspect the connections, such as the terminals at both the IMT actuator and the PCM, can help mitigate connection-related issues. Environmental factors and everyday wear can affect these connections over time, so proactive maintenance is key. Consider documenting all maintenance activities to build a reliable history that could aid in diagnostics. Understanding the importance of preventive measures allows you to extend the life of both the vehicle's components and overall system longevity. In summary, the DTC P1077 indicates that the IMT valve is stuck in a high RPM position, affecting engine performance. Understanding the critical role of the IMT valve and the accompanying components is essential for effective troubleshooting. The diagnostic process involves various steps, including electrical checks and continuity measurements. Timely recognition of symptoms and diligent follow-up on repairs can prevent further complications. Additionally, implementing a preventive maintenance strategy can help mitigate similar issues in the future. Always remember that consistent diagnostics and maintenance are key to preserving the performance and functionality of your Honda Odyssey. Please like and subscribe to the channel. See you next time.